Hey there, grade 5 teachers. Let's have a look at some ways that you can connect computer sciences into your space unit. Your computer sciences in grade 5 talks a lot about design thinking, engaging in the design process to create computational artifacts. It talks about creating a set of instructions and identifying computational thinking used to solve problems. We know that overarching organizing idea for computer science covers computational thinking, design thinking, and creativity as being the key pieces of computer science. In grade 4, students are asked first to create artifacts. Artifacts can be algorithms, models, prototypes, programs, experiments, objects, pretty much anything that students are creating, designing, creating, building, and making. In grade 5, we continue to see that students are being asked to design an artifact. They're also being asked to design computational artifacts and to specifically use the design thinking process. So, by having students create models or prototypes or things that are representing other science systems using technology, you're also going to be meeting some computer science outcomes. Computational artifacts can be anything from actual block-based computer programs such as students could build in something like Scratch. It could be audio or video presentations. It can be a slides presentation or even a website. So if students are representing their learning, showing you what they know through one of these avenues, then they're also going to be meeting that computer science skill. Further to that, the grade 5 computer science is refers specifically to design thinking quite frequently and having students work through the design process. So any opportunities you have to have students use the design thinking process while they're working on some type of a project for you, they're going to be meeting computer science outcomes and practicing skills that come from the computer science curriculum as well, giving them opportunities to transfer the use of these skills into subject areas is just going to deepen their computer sciences understanding and giving them a really strong foundation for what they need to know in grade 6. Let's have a look at some of the specific skills and procedures from the space curriculum and some different ways that we can connect in some of the computer science concepts as well. So first, just looking at some of these skills and procedures related to the Earth's tilt and moon cycles. It doesn't say, well, I guess it does say seasons. So referencing, sort of how things in space are connected to time and our seasons here on Earth. We're going to look at some lunar and solar eclipses when we're talking about space. So really specific content there. Let's have a look at how computational thinking lens could be applied to these skills. So when we're breaking observations of the moon down into its various stages, if we happen to watch it and track it for that month, and then we're looking at can we group days together? Did it look the same? And then, what do these stages look like? Learning what those stages are. We're breaking that down into its various stages. That's some decomposition there. Understanding the different patterns in astronomical phenomena is a way to do some pattern recognition. Determining which observations are relevant when studying astronomical phenomena. So this is that abstraction piece where we're looking for just the relevant pieces. So if we are talking about seasons, what matters is the tilt of the Earth in relation to the sun, and where we are, say, in our rotation, that's an attribute that doesn't come into play if we're talking about seasons. In the reverse, if we're talking about the time of day, where we are at in our path around the sun isn't something that we need to be concerned about. We can abstract that down to only caring about where we are at in our rotation if we are making connections to time of day. And then we can always ask students to further the computational thinking to that algorithm design by simply asking them to write out sets of instructions. So for example, asking them to write sets of instructions for how to safely view objects in space and astronomical phenomena would be meeting computer science outcomes. Asking them to think about what are all those components of the safety steps and what order do they need to be in to make sense and to meet the end goal of keeping yourself safe when you're viewing these astronomical phenomena. That is computer science, computational thinking. We're going to be doing some algorithm design in there, and that's going to help students get a deeper understanding of the computer science concepts and make some of those transfer connections as well. Having students create projects in Scratch specifically, and there are other online coding platforms that you may have your students use to create different types of projects, but students have the opportunity to create some interactive presentations, games, stories that are built with the block coding. So that's going to allow them to work on these skills specifically from computer science while showing you that they know some of these other knowledge, can do some of these other things from, say, their space unit. And we see here some First Nations, Métis, and Inuit perspectives showing up within your curriculum. And this is that opportunity to really hone in on the empathizing piece of the design process and draw attention to that. That's what we're doing when we're considering these other perspectives, when we're putting ourselves in their shoes, so to speak, and then connecting for students that that is a piece of the design process, and that when we're, working on creating a new design for something, the very first piece we need to think about is, who this project is for and how we can make sure that we meet the needs of that who. So any opportunities to have students just look at something from someone else's perspective is a great connection into the design process. Having students use a program like Scratch to do block-based coding to create projects that demonstrate their knowledge from other science topics is a really great way for them to learn those computer science skills and refine the computer science skills and even demonstrate that they have that solid understanding. Again, with represent connects into being able to create an artifact. We could have students create a physical model of astronomical phenomenon. We could also be doing this again through Chromebooks or on some other type of technology so that we're doing computational artifacts, and we're really going to have an opportunity to hit all of the skills and procedures in both of these understandings from computer sciences if we extend, and especially if we have students actually using a block-based coding program to create those computational artifacts. We're giving them coding skills, meeting computer science outcomes, and hopefully allowing them to have some fun with the projects they're creating too. So those are some ways you can connect computer sciences into your space unit. I hope you enjoyed.